Welcome, my friends, to your channel. Today, we are going to talk about RAID technology, and we are going to see the configuration of different types of RAID. But before we start, please don't forget to like, share, and subscribe. Data is the main important issue in any company. We may reinstall operating system and reconfigure the applications. However, if data got lost for any reason, then it is considered a disaster since it's really impossible to restore the data, or in the best case, it will cost time and money to restore the lost data. Thus, conserving the data is one of the main strategies of any company. This is why when we talk about storage, there must be a way to conserve data, nevertheless, to back up this data. Here, where we come to RAID technology, and we will start talking about what is RAID. RAID will help us conserve the data by distributing the data written on certain storage into different hard disks, as we will explain. It's necessary to configure RAID on servers as well as the storages in order to conserve the data. There are different type of RAIDs. We will explain RAID 0, RAID 1, RAID 5, 6, RAID 10, RAID 50, and RAID 60 all together, and we will see the differences and how to choose each type of RAID in which place. We will start talking about RAID 0. RAID 0 is the only RAID that accepts one hard disk only, and it may also accept several hard disks. The rest RAID types require more than one hard disk, as we will see. RAID 0 is used to fasten the process of writing data on the hard disks. It may be used, it's usually used with for caching the data, and it's also used with other RAID types in order to fast the write of the data, in addition to conserve this data. Another information about RAID 0 is that it may take a different size of hard disks. It's not required to have the same size of hard disk as we will see in other RAID types. How to calculate RAID 0? If we have, for example, 3 hard disks, 1 terabyte, 4 terabytes, and 3 terabytes, then the result will be 7 terabytes of storage. However, as you may see in the hard disks, in the data written on the hard disks, it's not the same on all hard disks. For example, in hard disk 1 we have B1, while in 2 we have B2, and then B3, then we back to hard disk number 1, B4, then B5, then B6. It's not the same type of data. This leads us to the result that if one of the hard disks failed, then we will lose the data, because there is no conservation for the data in RAID 0. As we said, it's used usually for caching the data, it's for data cache, or to fasten the write of data in other RAID types, as we will explain later in this video. Moving to RAID 1. RAID 1 is one of the most reliable RAIDs. It consists of 2 hard disks of the same size. The data will be written on both hard disks at the same time. As you may see in the image, it's writing A, B, C, D, E, etc. on both hard disks. We have the same data on both hard disks, so in case one of the hard disks get failed, it will not matter. The data is safe on the other disk. We just replace the failed disk and everything will be fine. RAID 1 is usually used with the server configuration in order to conserve the operating system and its features. So instead of one of the hard disks failed for any reason, we just replace the failed hard disk and the data will start to rebuild again from the other hard disk. One last information about RAID 1 is that in case we use two different size of disks, the RAID will be built over the lower size disk. For example, if we used 1 terabyte and 2 terabyte hard disks, then the RAID will give us a size of 1 terabyte only. Moving to RAID 5. RAID 5 uses what is called parity in order to conserve data. As you may see in the image, when we write the data on RAID 5, it starts writing A1, A2, A3, A4, and then it gets the parity of these A's and write it in the fifth hard disk, which is AP. To simplify the parity, it's something like an equation. For example, I can say A1 plus A2 plus A3 plus A4 equal AP. In this case, if one of the A's gets missing or in one of the disks get missing for any reason get failed, then I will have one equation with one unknown, so I can recalculate the missing value easily. As you may recognize also that the parity is moving from one disk to another while we are writing the data on the disks. This will help RAID 5 to fasten the write of data on the disks, and also it will fasten the rebuild process in case of one of the hard disks failed. The RAID 5 will allow you to have one failed hard disk at the same time. So if one of the hard disks gets failed, you will just replace the disk and the data will rebuild again. In case two hard disks failed at the same time, you will lose all the data. The disks of RAID 5 must be of the same size, and to calculate it, for example, here we have 5 disks. If we have each one is a 1 terabyte size, then the value of RAID 5 will be 4 terabyte storage. Continuing to RAID 6. RAID 6 also uses parity, same as RAID 5, but instead of using one parity, it uses two parities to conserve data. This will give us the option of having two equations with two unknowns, which means if we get two disks failed at the same time, then we can replace both disks and data will get rebuilt again. As in RAID 5, we only have the ability to lose one disk. In RAID 6, we have the ability to lose two disks momentarily. However, RAID 6 will lose more space of the storage. For example, in these 5 disks, if each one is 1 terabyte size, then the size of RAID 6 will be 3 terabytes only. So we lost more storage than of RAID 5. Of course, all the disks in RAID 6 must be the same size, similar as RAID 5. So here comes the question that may occur to most of you: when to use RAID 5 and when to use RAID 6. Here, the decision depends on whether we want to have more storage or we want to conserve the data. For example, if we have a backup of the data on the storage, then we may go to RAID 5 since we will have more storage capacity. But if we don't have backup of our storage, then we may consider of having RAID 6 since we want to conserve the data and not to lose the data in case of more than one hard disk gets failed. Well, my friends, we will continue in the next video to talk more about RAID types and RAID configuration. Please don't forget to like, share, and subscribe.